Yes, yes, guys. Not stuck. I went outside. Sorry for for inconvenience. Okay. So here what we have did is just let me run it once. In main thread. Okay. Please define the main method as what main. Okay. Yeah. I need to create objects, right? Yes. Oh, why employee? This method error. Employee defined. We will be saying that default. So, here is no EMP is in some. Yeah, yeah, here we go. So we just call the constructor here. Nothing to worry about. Okay. See, let me explain it for you. What I have done here is we just invoked a constructor. Okay. So here we need to change it for this keyword. Okay, this keyword, not as an old constructor. Okay, we need to change it for this keyword. So we'll be calling this constructor, which is having the parameters in the constructor which is default. Okay, so then what happens whenever we call this our constructor of our class, what happens is this is called first, means this constructor is called first and operation in that constructor is performed, and then next our default constructor is called. Okay, if I create one more constructor, p, it says int emp id comma int emp salary, and I say emp id plus emp okay, and if I do this, sorry, I haven't called this one here. I'd call this by saying this of 25 comma and the semicolon and running. Okay, what happened here is this is called this one. Okay, this one called this one. and this got printed at first, then this got printed at second, and then our default constructor is called. So this is what we call as constructor chaining. Okay, which means calling a constructor from another constructor. Okay, is it clear for you guys? Is it clear for constructor chaining? Yes, yes. More responses, please. More responses, please. Yes, sir. Can you repeat again? Yes, I can. Okay. What happens here is just let me download. Okay. Here, constructor chaining means calling a constructor. There is a constructor in our class, right? Default constructor. This is our default constructor, right? This is and then what we have invoked a constructor of in our class, and then we overloaded the constructor. Okay, we have done constructor overloading with employee ID number. Okay, then what we are doing here is we are calling this constructor inside this constructor. Okay, we can also call this constructor inside this constructor. How? By increasing parameters. Okay, 35,000. Save and run. Okay, see, I got the input, output. Okay, so constructor chaining is nothing but calling one constructor from another constructor. That's it. Which are overloaded or which are containing parameters. You cannot create one more constructor with the same name and same parameters. Okay. Yes. 7. M7, is it clear for you? Yeah. Yep. Okay. And now we'll be seeing some concepts or getting introduced to a OOPS concepts. Getting introduced to a OOPS concepts. So what are OOPS concepts? What is meant by OOPS first? Yes, chat. What is meant by OOPS? So I don't need any abbreviation for this one. I need its definition. Yes, I need its definition, please. What is meant by OOPS concepts? Nice all classes. Yes, yes, yes. Information. Yes, yes. Everything in Java that is interrelated to object methods, reusability. Okay. Reusability, efficient use in Java. Yes, yes, yes. Oops. Okay. See, oops is a programming paradigm. Paradigm means method or okay, method or a process. Okay, which relies on objects. Okay, which are our real world entities. Like just say example for animal is an object, right? Animal is the object, right? And animals, apple, animal, apple, we say wall, okay, laptop, mobile. These all are our objects, right? So we will be working on these objects, real world objects. Okay. Okay. We'll be working on these real world objects in OOPS. Okay. Yeah, not via encapsulation. Encapsulation is something different concept in OOPS. Okay. So for performing these, so for performing or for working with these objects, we got introduced with our OOPS concepts. Okay. Our OOPS concepts consist of inheritance, abstraction, okay, encapsulation, and polymorphism. Okay. So in these OOPS concepts, we also consider classes and we also consider objects. Okay, classes and objects also come under the concepts of OOPS. Okay. So let's just start with classes. Okay. Let's just start with classes. Classes. Okay. There are different types of classes in Java. What are all they? We call them, we will be having different types of classes in Java. So we all know what is a class. What is a class? Everyone, what is a class? Yes, everyone, what is a class? Yes, a class. is a blueprint for creating objects. Okay. The class is a blueprint for creating objects. Okay. So we'll be having different types of classes in Java. Okay. First one is abstract classes. Abstract classes which which doesn't create objects. These abstract classes doesn't help us to create objects. Okay. And there are classes like abstract classes, and then we'll be having concrete classes. Okay, concrete classes, which are our regular classes, which allows us to create objects. Okay, and there are final classes, which can't be extended furtherly. These cannot be extended or inherited. Okay, these final classes cannot be inherited by another classes. Okay, and there is inner classes, which are class inside a class. Okay, and there are classes, we say anonymous classes. Anonymous classes. These classes are contains these classes contains all other classes. Okay, these classes contain all other classes. Okay, so these are the types of classes we will be working in Java. These are the types of classes we will be working in Java. Okay, see, yes. So we'll be discussing these things furtherly when we are going deeply into our OOPS concepts. Okay, and some so while we are for writing these OOPS concepts or where we are using these OOPS concepts, there are some major and minor elements to be followed. Okay, there are some major and minor elements to be followed or to be seen for creating these classes or these working with these OOPS concepts. So what are they mean? There are some major elements such as abstraction. Okay, I think you know what is meant by abstraction. Hiding the data, right? Encapsulation. Yes, yes. Abstraction means hiding the unnecessary data. Okay. Encapsulation, and we will be having something called modularity. Okay, we'll be having something called modularity. I'll be explaining these things now. Okay, don't worry about these things. Let me make it clear for you what are all the major and minor concepts to be followed or to be which are present in our classes. Okay, and hierarchy. Okay, so these are the major elements in our classes to be followed, and there are some minor elements which are persistence, and typing and concurrency. Okay, these are the 7 major and minor concepts which we will be following in our OOPS. Okay, which we will be following in our OOPS. Okay, let's just dive into these things. What are these things? We'll be seeing. Yep. The first one is abstraction, right? Okay. The first one is abstraction. Abstraction is denotes as the characteristics of an object that distinguishes it from another objects. Okay. Okay. In this abstraction, the characteristics of an object distinguishes from another object, which mean the process of hiding data which we will be implementing by the objects, so that there is no interconnection between two objects, or there is no possibility of data sharing between two objects. Okay, the process of hiding characteristics of one object from another object. Okay, it is a process of hiding the implementation details of one object from another object. Okay. Okay. What is the help of this thing? The help of this thing is will be only getting to know about the functionality of our objects, but not the internal details, right? So for this one, we can consider an example of how a company works, right? Whenever when there are companies such as when there are big companies, they will be knowing about their functionality, right? Service based companies means which will be providing service to other companies. Okay, which will be providing service to other companies. So how they work, it will be kept secret. How they work, what they are working on will be kept secret. But they will be knowing the functionality on what are the things they are working. Their work will be kept secret, but the thing they are working will be open. The function, the functionality they are working, what are the all things they are working will be open, but the work they are doing will be kept secret. Okay, this is the abstraction. Okay, and then the next one is encapsulation. Okay, encapsulation is a process of hiding data. Okay, which constitutes as abstraction. Okay, so using encapsulation, we simply hide data. Okay, over the see encapsulation is a layer over abstraction. Okay, encapsulation is a layer over abstraction, which means which is we are compartmentalizing we are storing our data in a compartment. That's the we will be storing our data in a compartment and blocking the compartment simply. For this one, we can consider the example of a tablet, pills, right? Tablet pills, right? We will be having some homeo pills, something, or I think, where the medicine is kept inside and it is covered with a plastic biodegradable covers, right? So that we cannot open them and destroy them. In the same way, our encapsulation also work. So what is the help of encapsulation is it improves the structure of our code. Structure of our code, okay? And behavior will be much more better. Behavior of our code will be much more better. Better. So to get encapsulation, we will be using keywords such as private. Okay, we'll be using keywords such as private, protected to our classes or to our abstracted methods. Okay, we'll also be using abstract for these classes or methods. Okay, okay, so that we can hide our data. Our data cannot be accessed without our permission. Okay, you can only our data can be accessed only when we permit the user to use. Okay, and then the third one is modularity. See, modularity. See, for this one, we can simply say replacement. Replacement, which means there will be some parts of if you consider a car, just consider an example of a car in which we can simply replace some parts, right? Yes or no? We'll be replacing our parts, right? Some parts. Yeah. So modularity helps us to make loose coupling. Helps us to make loose coupling between our objects or objects. Okay. Objects, so that we can replace them whenever we want. Without changing the entire code. Okay, without changing the entire code. Okay, so what is coupling, sir, mean? By the way, what is coupling, sir? Coupling means whenever we are creating objects, right? Just consider the previous example. EMPLO employee employee EMP is equals to new EMPLO employee, right? This is how we created our object, right? EMP dot EMP ID. This is tightly coupled. Okay, this is called tightly coupled, which cannot be break. Coupling means just connecting two objects or connecting our objects. Okay, so in coupling we'll be having two types: tightly coupled and loosely coupled objects. Okay, tightly coupled and loosely coupled objects. So here we'll be saying this one as one-to-one relation. We'll be saying this as one-to-one relation. We can only use this object at once. Okay. Okay, one-to-one relation. But whereas we can create objects like there are in advanced Java, we can create objects using using XML files. Okay, using XML files where our objects are loosely coupled to our classes, so that we can use them for one-to-many relations. For one-to-many relations. Okay. Here I can use this object only once with this only class, so that I cannot use this object outside this class. Okay. Outside this class, without creating these objects of this class, I cannot use this EMP ID. Okay. But where it comes to loose coupling, we'll be using XML files where objects are created with XML files whenever required. Okay. We will be giving only EMP ID. Objects are created based on this EMP ID. So like what happens here is we will be providing our XML file to create objects. Say if I say EMP ID for one person. Okay, it will create emp.id. Okay, if I call this emp id one more time, it will create emp1.emp id. Okay, so that our object is loosely coupled. We can use it anywhere. Okay, we can use this variable anywhere. So this can be made using our getter and setter methods in encapsulation. Okay, we'll be discussing them furtherly while we are discussing encapsulation. Okay, so this is a modularity, which is nothing but loosely coupling of our objects. Okay, and the next thing is aggregation. And the next thing is hierarchy. Okay, and the next thing is hierarchy. What it does is it allows us to make a proper ranking and ordering of our classes. It allows us to make proper ranking and ordering to our classes. Okay. So how can we achieve this thing? We can achieve this thing using composition and aggregation. Okay, there are methods to be followed for groups in which we follow hierarchy. We say it for composition and aggregation. Okay, so here aggregation means composition. We call composition as is a relation. Okay, and aggregation as has a relation. Okay, so the best example to explain this for you is a cat. Cat is a animal, right? But in aggregation we say a college has a department. Okay, so this comes into your inheritance concept. Hierarchy will be coming into your inheritance concept, where we will be discussing about this is a and has a relations deeply. Okay, we will be saying that a person is a Raju is a human, right? And Raju has a car. So there will be differences in inheritance. There are two types of inheritance. There are is a relation inheritance and has a relation inheritance. So we will be discussing these things in inheritance. Okay. So just remember this thing. This is followed in hierarchy, where we order our classes and where we properly rank our classes with aggregation and composition. Okay. Yep. That was for the day. I think I'll be and so much. Okay. So this is for the day, guys. We'll be discussing more from tomorrow. If you have anything to say, you can say, sure, sir. Yeah. Okay, sir, sure, sir. Okay, okay, Amma. Thank you. Thank you for your time.